Students, this question was asked in the year 1995 in IIT JEE exam from the chapter Units and Dimensions. The pairs of physical quantities, those have same dimensions, each are, there are four options given in ABCD: Reynolds number and coefficient of friction, Curie and frequency, latent heat and gravitational potential, Planck's constant and tau. Okay, student, we have to verify the dimensional formula for each of the 8 given physical quantities. What is Reynolds number, student? Reynolds number is the inertial force. This is the inertial force upon viscous force. Viscous force in study of the fluid dynamics. So the Reynolds number determines whether the flow of the liquid is streamlined or turbulent. Okay, student. Then this is the ratio of two forces, Fi and Fv. Then this is mlt minus 2 upon mlt minus 2. So this is dimensionless. Reynolds number is dimensionless. What is coefficient of friction, student? This is noted by mu, and this is also the ratio of two forces. Here the force of friction between two surfaces and the normal force between the two surfaces, normal force. So this is also a ratio between two forces, and that is F say friction and F normal. Okay, student. Then this is also mlt minus 2. The dimensions of frictional force, dimensions of normal force is also mlt minus 2. So this is also, or mu or coefficient of friction is also dimensionless or have dimensions L0, L0, T0. What is Curie, student? 1 Curie is equal to 3.7 into 10 to the power 10 integrations 10 decay, student, 10 to the power 10 decay of radioactive atoms, or that is equal to 1 gram of radium. 1 gram of radium disintegrates 3.7 into 10 to the power 10 atoms of radium atoms disintegrate per second. Okay, student. Then we know the unit is per second, or that is T inverse. And what is the dimension of frequency, student? Frequency, by definition, frequency is equal to 1 by time period T, the number of oscillations per second or the number of vibrations per second. So frequency also have, student, dimensions T to the power minus 1. So Curie and frequency both have dimensions T to the power minus 1. Then what is latent heat? Formula for latent heat, students. Latent heat is noted by capital L. Okay, student. And this is given by the formula Q is equal to ml and L is equal to Q by M, where Q is the heat and M is the mass. So this is mlt minus 2 is the dimension of heat, student, divided by mass. So this becomes L T to the power minus 2. And what is gravitational potential, student? Gravitational potential energy, PE, is equal to, you know, mgh. Okay, student. And this potential energy per unit mass is called gravitational potential. By definition, gravitational potential is potential energy per unit mass. So mgh divided by m is gh. Okay, student. Then the formula for gravitational potential is gh. So its dimension will be equal to dimensions of g. What is g? G is acceleration due to gravity. Its dimensions is lt minus 2 and dimensions of s, student, is length. So the dimensions of gravitational potential is L2 T minus 2. Okay, students. and sorry, I written here L. This is ml2 T minus 2. Heat is one form of energy, and every form of energy is ml2 T minus 2 divided by m is L2 T minus 2. This is also L2 T minus 2. So latent heat and gravitational potential also have the same dimensions. Curie and frequency have the same dimensions. The Reynolds number and coefficient friction also have same dimensions. Let us see the fourth option, that is students Planck's constant and torque. We know Planck's constant is noted by students H, and the relationship between energy and frequency is given by energy and frequency of the radiation, or a quantum or a photon is given by E equal to h nu, where E is the energy of the radiation, nu is the frequency of the radiation, and s is Planck's constant. From this we get student the formula for Planck's constant is equal to h nu. So dimensions of h is dimensions of E by dimensions of nu. The dimensions of energy is ml2 minus 2 upon this is t minus 1, the number of vibrations per second. So the dimensional formula for angular momentum, Planck's constant H will be equal to student m L2 t minus 1, which is the same as that of angular momentum, because ml2 is I and t minus 1 is omega. I omega is nothing but L, angular momentum of a body. And what is torque, student? We know torque is a vector denoted by tau, that is the cross product of F cross R, force cross distance, and the magnitude is given by tau Fr sin theta. So the dimensions of tau is equal to students dimensions of F, dimensions of R, and dimensions of sin theta. Sin theta is a trigonometric ratio. It is a ratio of two lengths. Okay, student. This is dimensionless. Then what is the dimension of force? mlt minus 2, and that of R is L. So the dimensions of torque is ml2 t minus 2, the same as that of work and energy, and not equal with Planck's constant. Planck's constant is ml2 t minus 1, which is equal with angular momentum. So student, D is not correct, but according to the question, options A, B, C are having the pairs of physical quantity, with those have same dimensions. So our answer will be A, B and C, students.